All right, let's dive into something that on the surface looks incredibly boring, a US military standard document. But what if I told you that this dry technical manual is actually the secret blueprint that makes sure some of the most advanced technology in the world actually works, stays secure, and can be kept running for decades to come? It's fascinating stuff.
So, to really get why this document even exists, we first have to wrap our heads around the fundamental challenge it was designed to solve. And it all starts with something known as the firmware problem.
I mean, it sounds pretty simple, doesn't it? But really think about it for a second. You can't just drag and drop a file onto a microchip. There's this huge gap between the world of code, the software, and the world of silicon, the physical hardware. So how exactly do you bridge that gap?
On one hand, you've got software. It's flexible, you can update it, you can change it, and it basically tells the physical parts what to do. And on the other hand, you have the hardware itself, the actual chips and boards, which are, for the most part, fixed and permanent. They just do what they're told.
Well, the bridge connecting these two worlds is something called firmware. It's a special kind of software that's basically burned right into the hardware, giving it its most basic, essential instructions. Think about the simple software in your microwave or your TV remote. That's firmware. It's what makes a device boot up or even know what its own buttons do. It's kind of like the permanent soul of the machine.
Now let's scale this up. Imagine you're not just dealing with one microwave. Imagine you're the military. You've got thousands of identical systems out there in jets, on ships, in critical communications gear. How in the world do you update all of them? And how do you guarantee with 100% certainty that every single one is programmed exactly the same way and that the update worked perfectly? We're talking about mission-critical systems here, where a single tiny error could be absolutely catastrophic.
When you're facing a problem with stakes that high, you can't just wing it. You need a bulletproof, completely standardized process. You need an official solution.
And here it is. It's not a flashy piece of tech, it's not some cool gadget. It's a document with, let's be honest, a very bureaucratic name, DI-PSC 81448B. This right here is the US Department of Defense's highly detailed official answer to the firmware problem.
And the document itself tells you its purpose right up front. It's designed to provide, and I quote, the information needed to program and reprogram the firmware devices of a system. Basically, it's the master key for any and all firmware.
So let's just forget that long, clunky name for a minute. The easiest way to think about this is that it's the ultimate, most ridiculously detailed instruction manual you could ever possibly imagine for a single microchip.
Okay, so what in the world does a manual like this actually contain? What makes it so special? Let's crack it open and take a look inside to really understand its structure.
The whole thing is really built on 4 key pillars. It covers the scope, like what devices are we even talking about, then the reference documents you might need, and of course the notes with all the acronyms. But the real heart of it, the part that truly matters, is Section 3, the programming instructions.
This is where the magic really happens. Section 3 is the engine room of the whole operation. It contains the literal step-by-step instructions for getting that code onto the chip. It is the absolute core of the entire standard.
So let's zoom in on that section, because this is where you start to see just how incredibly detailed this blueprint really gets.
This section leaves absolutely nothing to chance. For every single piece of firmware, the manual has to specify exactly what device is being programmed, exactly what software is being loaded onto it, the exact equipment you must use to do it, and the precise step-by-step procedure you must follow. There is zero room for guesswork here.
And that really reveals the core philosophy behind this whole thing. Absolute, total precision. The standard covers the what. That's the chip and the software. It covers the with what, the programming tools. And it covers the how, the exact steps to take.
And honestly, the level of detail is just staggering. It's not good enough to know the model of the device. You need the manufacturer, the memory size, the pin layout. The software needs a project-unique ID, right down to the specific version and release number. And get this, even the specific manufacturer and model of the programming tool you use is mandated. The procedure itself becomes the super rigid checklist. Step 1, erase. Step 2, load. Step 3, verify. Every single possible variable is completely locked down. Okay, so it's incredibly detailed, almost obsessively so. But why? Why go through all this trouble? Why does this level of bureaucratic precision actually matter out in the real world?
Well, it's because this document isn't really about paperwork or just following rules for the sake of it. It's about embedding reliability into the very core of a system. You could say it's the genetic code that ensures a piece of technology is going to perform exactly as it was designed to every single time.
And the benefits of this are huge. First, you get consistency. Every device in every jet works exactly the same way. Second, you get maintainability. A technician 30 years from now can pull this manual and know precisely how to support that system. And finally, you get security. This tightly controlled process makes sure no unauthorized or malicious code ever makes its way onto the hardware.
Think about that. What this standard really does is allow you to build a critical piece of hardware today with total confidence that it can still be safely updated, repaired, and maintained way out in the year 2050, long after the original engineers have retired.
It really makes you think, doesn't it? This is just one standard for one very specific task, and it kind of leaves you with a bigger question. What other invisible blueprints and silent rulebooks are out there quietly making sure that our incredibly complex technological world continues to function day in and day out?